Hello and welcome to Scholar Fedu. This is our JAMB web series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we're looking at the UTME questions for chemistry for the year 2016. This is the first part of the recording. We are going to look at the first 20 questions. Before we continue, please don't forget to subscribe to our channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. Alright, first question here on atoms, elements, and compound. An element X has two isotopes, okay, 10x20 and 1022x, present in the ratio 1 to 3. The relative atomic mass of X would be. Now, what we have here is that one of the isotopes of this element X has an atomic mass of 20, and one of it has an atomic mass of 22. Now, let's say we have an element A, okay, an element A having this isotope here, this abundance here. It has p% of Y and q% of Z. All right, you will say that the relative atomic mass of this atom A is equal to p% of X plus q% of Z. But if you look at this question here, they did not give us the percentage composition. What they give us is the ratio. So what we are going to do is we are going to use that ratio to get the percentage composition. Okay, so how do we do that? Now, the whole ratio, that means the whole percentage, okay, is 100%. All right, so you want to know that this one that has a ratio of 1, what is it going to be in percentage? This one that has a ratio of 3, what is it going to be in percentage? So to do that, first we are going to find the sum of the ratio. All right, meaning we want to divide this 100% in the ratio 1 to 3. So we start by finding the sum of the ratio, that is 1.1 plus 3, 4. Then for the ratio 1, we are going to have 1 over sum of the ratio, which is 4 times 100. Alright, 1 over 4 times 100 will give us 25%. Alright, that is, we are going to have 1 times 100, that is 100 divided by 4, and that will be 25%. For the other isotope that has a ratio of 3, we are going to have 3 over the sum of the ratio, which is 4 times 100%. And that will be equal to 3 times 100 is 300 divided by 4 is 75%. So that means that the abundance of this isotope is 10% of this and 75% of this. So that's so we can now use this formula here. All right, that is 25% of this plus 10%. I mean 25% of this plus 75% of this. 25% will mean 25 over 100, and 75% is 75 over 100. 25 over 100 is, if you divide 25 by 100, you get 0.25. So you have 0.25 times 20 plus 75 divided by 100 is 0.75 times 20. So this times 20 is 5 plus 0.75 times 22. 22 here times 22 is 16.5. 5 plus 16.5, and that will give us 21.5. This is the relative atomic mass of the atom X. Alright, next question on gas law. 200 cm cube of oxygen diffused through a porous plug for 50 seconds. How long will 80 cm cube of methane take to diffuse through the same porous plug under the same condition? Alright, in solving this question, we are going to be using the Graham's law of diffusion. Alright, we are going to look at we'll be using the Graham's law of diffusion. Okay. Now, the Graham's law of diffusion states that the rate of diffusion is inversely proportional to the square root of the vapor density. Okay, the rate of diffusion is inversely proportional to the square root of the vapor density. For two gases, so if you have two gases, R1, two gases, let's say gas 1 and gas 2, that are diffusing under the same condition, then we have that the rate of diffusion of those gases is inversely proportional to the square root of their vapor density. If we turn this into an equation, we are going to have R is equal to K over root mu here, which is a symbol that we are using here to represent vapor density. Then this will become R1 root mu 1 equals R2 root mu 2. Okay, now the mu here represents the of course a symbol here. Okay, represents the vapor density, okay, of the gases. That is of this is of gas 1 and this is of gas 2. Now, since the density varies directly as the relative molecular mass, we can simply replace this with molecular mass. So instead of using rate and density, we'll be using rate and molecular mass. Okay, now for the oxygen, the rate of diffusion of the oxygen is going to be equal to the volume over time. For rate of reaction is the volume of the gas that is produced, okay, or that is used up over time. So for the oxygen you rate, okay, let's say the oxygen is the gas 1 and the methane is the gas 2. So R1 for oxygen is going to be equal to the volume of oxygen, which is 200 cm3, divided by the time, which is 50. So the rate of diffusion is going to be 4 centimeter cube per second. While for methane it is going to be the volume 80 over, we don't know the time for this, okay, so we just limited that as T, okay, and that is what we have to find, how long, that is the time that it will take for this methane to diffuse. So we substitute this in the formula. Okay, we need one more thing here, and that is the molecular masses here, the molecular masses of those molecules here. So starting with oxygen, the oxygen is a diatomic molecule. Alright, it says as a diatomic molecule, so you have O2. So this will be equal to, the atomic mass of oxygen is 16, but we have 2 of it here, so this will be 16 times 2, and that is 32 grams. So that is the molar mass of this diatomic oxygen here. For the methane, you have CH4, so the atomic mass of carbon plus 4 times the atomic mass of hydrogen, and the atomic mass of hydrogen is 1, so you have 4 times 1, that is 4. 12 plus 4 is 16. So this is the molar mass of oxygen, and this is the molar mass of methane. We will now substitute that into the equation here. So the rate of diffusion of the gas 1, which is the oxygen, is 4 root the molar mass or the molecular mass of the oxygen, which is 32, equal to the rate of diffusion of the methane, which is 80 over T, times root the molar mass of the methane, which is 16. Alright, so here we are going to be having this here, this root 32 is going to become 4 root 2. How does it become 4 root 2? If you break you can break root 32 into root 16 times 2. Okay, root 16 times 2. Root 16 will now be 4. So you are going to have 4 root 2. And there's a 4 here already. So 4 times 4 root 2. I said this root 32 alone is going to become 4 root 2 if you break it down. Then 4 times 4 root 2 is going to become 16 root 2. Now the square root of 16 there is going to be 4. So the 4 here can cancel the 4 here. But you know you have 6. This is now 16. This becomes 16 root 2. So you can say the 4 here in 16 root 2, and that will give you 4 root 2. Then from here we can cross multiply this. Okay, this time here. If you cross multiply the time, then you are going to have 4 root 2 times T. Okay, 4 root 2 T equal to 80. To get the value of T here, we are going to divide both sides by 4 root 2. And if you divide both sides by 4 root 2 here, you are going to get approximately 14 seconds. Okay, you'll be having 14 seconds approximately. Which of the following terms indicates the number of bonds that can be formed by an atom? That is the valence. Okay, the valency of an atom. That is the number of valence electrons that you have in the atom. The valence electrons are the electrons in the outermost shell of the atom. The number of those valence electrons indicates the kind of bond that that atom will form. The diagram above represents an atom of. So what we need to do is, what we can do is, from this diagram here, we can get the atomic number of the elements. And how do we do that? That is by adding up the number of the electrons that we have here, the number of the electrons that we have here. So these small dots here, okay, they are electrons. And in this shell here we have 2 electrons. Here we have 8, so we have 2 plus 8, and here we have 2 plus 2, so we have 12. 2 plus 8 plus 2, and that will be 12. So the element with the atomic number of 12, that is magnesium. Magnesium has the atomic number of 12. Next question: which of the following gases is the most dangerous pollutant? The sulfur oxide. Okay, the sulfur oxide is the most dangerous air pollutant. A side effect of salt water is that salt water attacks lead. Okay, it attacks lead. It reacts with lead that is contained in pipe. All right, it dissolves the lead in those pipe. Okay, the lead in those pipe is going to dissolve in the salt water. All right, and that lead is poisonous. Okay, it is poisonous. Farmlands affected by crude oil spillage can be decontaminated by. They can be decontaminated by using aerobic bacteria. Okay, aerobic bacteria are used to remove oil spill. Which of the following functional groups will give gas bubbles when treated with a saturated solution of sodium hydrogen thiazocarbonate 4? That is the functional group of the alkanoic acid. Okay, the alkanoic acid. Now, acid generally, when they react with thiazocarbonate, okay, with a thiazocarbonate or a bicarbonate, they produce salt, water, and carbon dioxide. Okay, carbon dioxide. The gas bubble that will be produced here are the bubbles of carbon dioxide. Okay, carbon dioxide gas. Okay, will be seen as bubble when you act sodium hydrogen thiazocarbonate with an acid. All right, and this COOH here is the functional group of the alkanoic acid. The oxidation state of chromium in potassium heptioxodichromate is, alright, we say that the sum of the oxidation number of the elements here is equal to 0. Okay, the oxidation number of a compound is equal to 0. Alright, then we will substitute for the oxidation number of the other elements here besides the chromium here. The oxidation number of potassium is 1, and we have 2 of it here, so we have 2 times 1 plus 2 times the oxidation number of the chromium, which is what we are looking for, so we now substitute for that, plus the oxidation number of oxygen is -2, and we have 7 of it in this compound, so this will be -2 times 7, and all of that will be equal to 0. So here we have 2 times this is 2 plus 2 times, okay, 2, let's just say 2c, then -2 times 7 is -14, plus times -14 will give us -14 here. Then we say plus 2 minus 14 on this side is equal to -12. So we have 2c minus 12 is equal to 0. You can then bring this -12 to this other side where it becomes plus 12. Then to get the value of c here, we divide both sides by 2. So we have our c out to be equal to 12 divided by 2, which is equal to 6. Which is the reason why this compound is named potassium thiazochromate 6. Okay, 6. So the oxidation state of the chromium here is +6. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. The substance that is oxidized in the reaction above is the water here. So oxidation is the removal of hydrogen or the addition of oxygen, and in this case, if you look at this compound here, alright, the hydrogen here has been removed, leaving only this oxygen here. Okay, so the removal of the hydrogen is oxidation. So the substance that is oxidized here is this here, alright, the water. Z in this diagram here represents the heat of reaction, or what we call the enthalpy change. Okay, the heat of the reaction, that's the heat of the product minus the heat of the reactant. Alright, you can relate this diagram with the diagram that I have here. This X that I have here, we call it the activation complex. The X and W here, we call it activation complex. This Y here, okay, or this U here is called the activation energy. Okay, it is called the activation energy. The C plus D here, or the X that is here, this is the product, while this is the reactant. Okay, this is the product and this is the reactant. The W at the top here, or the X here, is the activation complex. So basically what we have to identify is this Z here, and that is the heat of reaction. The nucleus of an atom contains 3 subparticles: the proton, the electron, and the neutron. Okay, the electrons are on the shell or in the electron cloud, while the protons and neutrons are what you have in the nucleus of the atom. So the nucleus of an atom contains protons and neutrons. These are the nuclear material in the atom.
Next, which of the following does not happen when a zinc rod is introduced into a solution of copper 2 sulfate? The temperature of the soil changes, of the solution rather changes. This does not happen. Okay, this does not happen. In fact, this does not even, it does not relate to the question, like the soil here, but I'm thinking this might actually be the solution. Okay, it might actually be solution, not soil. I will say the temperature of the soil, this is out of the sphere of the discussion. But other things that happen is the zinc displaces the copper. Okay, the zinc will displace the copper to form zinc sulfate. Also the copper will be deposited, all right, it will be displaced and deposited, and the blue color of that solution is going to fade away. Okay, the blue solution is going to gradually disappear. So all of that is correct. Next question, which of the following statement is correct during the electrolysis of a caustic soda solution using platinum electrode? The caustic soda solution is the sodium hydroxide, and during its electrolysis, sodium metal is deposited at the cathode. Okay, sodium metal is deposited at the cathode, while oxygen and hydrogen are libated at the anode and the cathode. Oxygen is libated at the anode, hydrogen is libated at the cathode. You also have sodium deposited at the cathode.
You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below.
Which of the following statements is incorrect? The fractional distillation will give the following hydrocarbons in the order of increasing boiling point. So these are the products of the fractional distillation of crude oil or petroleum. Okay, it will give these hydrocarbons here in order of increasing boiling point, that is from the one with the lowest boiling point to the one with the highest boiling point. So you have gasoline, then paraffin, diesel, then lubricants, and grease. So if you look at this, you can see that the boiling point of the petrol, okay, is greater than the boiling point of the kerosene. All right, if you look at this, you see the boiling point of the kerosene is greater than the boiling point of the gasoline, but here they are saying that it is less, so this is not correct. The iron 3 oxide impurity in bauxite can be removed by, it can be removed by the dissolution, okay, the dissolution of the iron 3 oxide or the bauxite in sodium hydroxide and filtration. Okay, dissolution first followed by filtration. Aluminum is extracted commercially from its ore by the electrolysis of fused aluminum oxide in cryolite. Okay, by the electrolysis of fused aluminum chloride in which of the following compounds give a yellow residue when heated and also react with aqueous sodium hydroxide to give a white gelatinous precipitate soluble in excess sodium hydroxide solution? That is zinc triazocarbonate. Okay, zinc triazocarbonate. When zinc triazocarbonate is decomposed under heat, when it is heated, okay, it will decompose to release carbon dioxide, leaving a yellowish zinc oxide, which will become whitish on cooling. When you add sodium oxide to this zinc oxide, a white gelatinous precipitate, okay, is observed, and that precipitate is going to dissolve in excess sodium hydroxide. The least easily oxidized of the metals below is zinc. Okay, the least easily oxidized from this option is the least electropositive of these elements here. And if you look at the series of metals, all right, from the most electropositive to the least electropositive, you see that from this option here, zinc here is the least electropositive of all the metals that I have here. All right, so zinc here is going to be the least easily oxidized. Which of the following chlorides will exhibit the least ionic character? That will be aluminium chloride. It is the least ionic chloride. It is only ionic as a solid at low temperature. Thus, its chloride has the weakest ionic character.
Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholar Fedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.